Alright, in the example here we have a child that's basically using a spring to bounce around. And what we want is we want an energy diagram for each of the positions. So as you look at the diagram, what you want to think about is what is listed in the, or what is shown in the diagram. Well, we have a spring, and so that's going to imply that we want to include elastic potential energy. Let's change from red to something else. We have a change in position, a vertical position. That implies we want to include gravitational potential energy. Now we don't have anything mentioning a rough surface or anything like that, so we don't need to include dissipated energy. Now we do have movement, so if we have movement, we want to make sure we include kinetic energy. That's supposed to be a K. So at position A, it looks like we have the spring compressed, so the little dashed position, that's your spring equilibrium position. Start with a circle of some size, and so we have the spring compressed, so we know we have elastic. We're at the lowest position, so we'll say the energy stored gravitationally is 0. And we haven't started to move yet. Position B, now we're at the equilibrium position. So we're not at the lowest position, so we have to have some gravitational potential energy. And we have to be moving. But the spring isn't compressed anymore, so everything that was elastic but stored elastic potential energy is now stored as kinetic energy and gravitational potential energy. Then at C you've reached the maximum height, and so now all of the energy is stored as gravitational potential energy. And that takes care of this particular case.